Hi all, welcome to day 14 of our 100 days of DevOps journey. So today, it is the second part of our Docker networking. Okay, so let's get started. So quickly, I just show you the recap of yesterday. Where did it go? Yeah. So yesterday we have discussed about how network address translation works and have seen some demo of bridge adapter, how bridge network devices in bridge network communicates, and how devices in net network communicates. So and also we have discussed about three networks. One is this one, default bridge network that is created in the Docker environment. Okay, then there is this user defined bridge network and host network. Okay, and we have discussed about their use cases and other things. So yeah, and moving forward, today let's discuss about some other networks as well. So there are let me just restart my VM. Okay, actually I don't want this window to show. Okay, I don't want this window. What I'll do, I'll just power it off, and there is one mode which is called start in headless mode. Okay, headless mode is it won't show me the UI. Whenever I want, I can check it, but it won't show me the UI. And there is this detachable start, it will show me the UI, but if I if I turn off that window, then also my VM would be running. So I'll be starting with headless, since we already have configured our static IP, so it won't be changing. If required, I can anytime open the window from here as well. Like there is one thing called show. Okay, enter. If I want to hear now, you can see continue running in the background. So even if I run it, I can continue using in the background. So that is called headless start. And now going to my terminal. This is okay. SSH re. Here also I'll just SSH. Okay. So this system is right now running. Let's just check docker ps-a. So yesterday we have set up one thing which is called new group, and how to add this 𝗖𝗃𝗃𝗃 user in DevOps group. So so now I don't need the sudo command to run it. So yeah, I'll be deleting this particular container, or I'll just show you one thing. Here this container, if docker inspect, first of all let me clear this terminal. Clear. Okay, docker ps-a docker container inspect void 2. So here, if you can see, we have configured it in nginx. What was I was going to show you was there is network type. I think there is some overlay to is the default one. Yes, network mode host. Okay, it is in host mode. So I'll just show you one thing. If I start void 2. Okay, now ps void 2 up for 2 seconds. It is up now. Okay, yesterday if you would have seen my yesterday's video or previous day video, so and there you might have noticed that it was not starting. Why so? Because if netstat hyphen -tup grep 80. So here we have created this container void 2, and now if we run on, yeah, okay, so here you can see, even though nginx is not installed on my system, it is showing nginx, this particular port is allocated to this particular process. This is the process ID. Okay, this is the process ID, nginx master over here. So here are these two ifconfig. We have this is the network adapter for our sguard network. And here if you can see, let me just readjust a little. So yeah, there is so if we have to check, we can go and check. Even though I'll just run the logs as well. So void is for host network. Okay, now I'm just deleting this this container, docker stop void 2, and it is deleted. Okay, now let's just go for our none network. Okay, clear. So none network, what is none network? Let's just go back to our whiteboard. So here all these networks are connected to our docker. Okay, they have their DHCP. Suppose if I just create this is none network. Okay, what it has, it does not has any DHCP server from the beginning. Okay, and if we create a particular container, like here we create a void over here. Okay, so let's just create a container. Where did it go? There is, yeah, actually, yes, over here. So this is none network driver. So if I just link over here, if I just create it, so it has only one network adapter, which is local. Okay, it does not have any other network adapter. And let me just create one more network none hyphen net, here is DIT network none, and then name would be void. Let's just say void. I think void would be good. Okay, here, or just say, yeah, I'm very confused with names, so no worries with that. Name void, and where did it go? -p port. Suppose I exposed it to port 8080. Okay, yes, port 80 nginx. It got started. Okay, and if I check docker inspect void, so here you can see there is no gateway, no network address. Okay, and similarly there is a network type would be where did it go? Memory swap, device driver network. There is one more thing. Okay, so here you can see there is network void is the name, network mode is none. Okay, we tried to bind the port with this, but we do not, since we do not have any particular gateway over here, so there is no way we can reach out to this port. Okay, we can try it out, but unable to connect. Why so? If I just go to docker logs -f void, so even though we have tried to multiple times, port is correct, allocation is correct, everything is correct, but we cannot check it over here. So it void apt update -y apt install ip route 2, and which one was that? if net tools. So here if you can see, nothing can be installed over here. It does not have like ping. Oh, ping command would not work even with this. So that's how if in this none network, it is an air gapped system, so it is mostly used for like processing, batch processing of sensitive data. Okay, and there are like some kind of if we have to check if we downloaded a particular updates. Okay, if we have downloaded particular updates, so how are they performing? Okay, we can do one thing actually over here. There is one catch. So let's just say, yeah, so here what you can put data into this. How so? I think, yeah, test for none. I have created this file. This is test for none. So it is a blank file. Okay, docker cp test for none void and slash. Okay, successfully copied. And if we just go into this ls, so here you can see the file. Okay, this is the file that is currently. So you can copy data into it, but you cannot directly download it from the internet. Okay, or you cannot have any access. Okay, if I just show ip command is also not there. So there is no network, no gateway, only local network is available. So that's how this particular thing will work. Okay, so I'll just docker stop void. Okay. So this is the null network. So here we have checked the none network. Now let's go back to our documentation. So none network has its own benefits and downsides. So everything you can use in your particular as per your requirement. Okay, now let's go to the next network type, which that would be 𝗏𝗏𝗏𝗏. Okay, 𝗏𝗏𝗏𝗏 network driver is mostly it works on layer 2 of the OSI model. Okay, just a moment. Yeah, layer 2 of the OSI model. And you can description, this is the 𝗚𝗏𝗡𝗏 mode default bridge. So what does 𝗚𝗏𝗡𝗏 do? Okay, I don't think there is one application over here. So 𝗚𝗏𝗡𝗏 is basically, there are some configurations that we need to do. So this is the none network. We'll just shrink it a little so that we can have some room. Okay, this one is void. No, we have two voids, but every other container is like connected. Every other network is connected to it. Okay, but this none is completely isolated. Okay, I'll isolate it. I'll just create one more brick wall kind of thing. Like I just, yeah, thick wall. Okay, it does not have any escape, so no connectivity in this none network. Okay, now there is one more interesting network type which is called 𝗚𝗏𝗡𝗏. 𝗚𝗏𝗡𝗏 is basically where, yeah, I'll just put it over here. 𝗚𝗏𝗡𝗏. Okay, this 𝗚𝗏𝗡𝗏 network adapter directly shares your uh, host network configurations. So it use DHCP from here. Let's just see how can we configure. So DHCP directly connected to this. So in this, let's just create the 𝗚𝗏𝗡𝗏 network. Okay, here if you can see 𝗚𝗏𝗡𝗏, yeah, we are in 𝗚𝗏𝗡𝗏 mode. So create a net in bridge mode. 𝗚𝗏𝗡𝗏 traffic goes through a physical device. So here we have this 𝗚𝗏𝗡𝗏. Okay, 𝗚𝗏𝗡𝗏 network. So 𝗚𝗏𝗡𝗏 network runs on layer 2 of OSI model. Layer 2 means, what does it mean? Layer 2 means it is on data link layer, which is just above the physical layer, and they have this IP and other things, MAC address allocation. Okay, in this. So it is mostly required for hardware, but how can we do that? Like it is used for IoT devices. Okay, IoT devices which requires their own MAC. Okay, so that's how this 𝗚𝗏𝗡𝗏 is used. IoT devices emulating physical hardware, IoT emulators mostly. Okay, like some camera or something like that. So how can we set it up? There is one thing that we have to set up. So it requires subnet of what? Your local network. Here like I'll just show you one thing. So if we just go ifconfig, so if you can see, this is the net gateway. Okay, it can be created for net as well, it can be created for bridge as well. So what we'll be doing is we'll be creating it for bridge network first. So docker network create, and there would be docker network create -d, which would be 𝗚𝗏𝗡𝗏 adapter, and there is this subnet. Okay, what is the subnet? 192.168.1.0/24. This is the subnet. Okay, this is the subnet. Or there is one very interesting thing that we can do here. If you want to run a longer command, okay, so you can put \, and here you can continue in the new line. Okay, and there is subnet would be 192.168.1.0/24. Okay, this is the subnet. And one more thing that we need to provide, which is gateway. Since it does not have its own, it does not create its own gateway, we have to provide it our gateway, which is 192.168.1.1. okay, this is the gateway that we have provided. Now there is one more thing, -o parent. So how would it be? -o, if you can see, where was that? There is very important thing. Docker network create. So -o you can see opt map. Okay, set driver specific option default map. Okay, we have to map what do we have to map, which is the parent. Okay, parent means this parent means the Ethernet adapter. Okay, so what was the Ethernet adapter that we were using? ENP0S3. ENP0S3. This is the Ethernet adapter that we were using, and here is the network name. So I just mpeg VLAN bridge. Okay, Mac VLAN bridge. So here it has been created. Docker network ls. Yeah. So here, where did it go? Docker network create requires one argument. Oh, I think. Let me add. Yeah, now it is created. So here you can see Mac VLAN bridge. Okay, since we have created it with our host bridge, so it is now up. So what does it do? I'll just create what it does it. If I run docker run docker run, we have created Mjolnir and others. So this is directly connected to that. Like what would be the name? Name would be like, just make it Wolverine. Wolverine network name. I'll be using Ubuntu for this. Network name Mac VLAN bridge. Okay, Mac VLAN bridge will be using this particular network. Driver we can also select, but I have select Mac VLAN bridge. Okay, and then Ubuntu we have created. Then there is Deadpool. It is also Mac VLAN bridge. And there is, was it Professor X? Professor X. I'll be creating it -p port 9999 port 80 and then Nginx. Okay, so we have these three containers available: Docker ps-8, Professor X, Deadpool, Wolverine. Okay, so now interesting fact over here is I am, let me check if they are running now. Docker inspect Wolverine. So here, if you can see gateway, and this is the IP address of that particular container. Okay, similarly Deadpool, this is the IP address of Deadpool also. Then we have Professor X. Yeah, this is the IP of that particular. And what I can do here is, if I have to ping any of that container, ping 192.168.1.2, I can ping it directly. So that is the beauty of Mac VLAN adapter. Okay, in fact there is, here you can see it has provided MAC address to all of these, all of the containers. Here this is the MAC. Okay, if I'll just copy, find, so this is the MAC 04, then 02, and then 03. So this is the this is how you can make it. And what we can do here is, yeah, so if I have to check if my this is working, which one, Nginx is working, what would be the IP? 192.168.1.4, and this is obviously exposed to 9999. What is that? 92.168. What is the IP? This is the IP. Docker logs -f Professor X ready to start up. Or let me just create it. Docker stop Professor X. Let's run it on port 80 itself. Port 80, it is running, working also. Ping 4. Why is it not getting pinged? We have this IP. MAC address is also allowed. We are able to ping 2. Yes. We are able to ping 3. Oh yeah, I know what's happening over here. Just a moment. There is one thing that we need to do. Remember yesterday we have talked about IP spoofing. So MAC address spoofing. First of all, we have to stop this particular container. Then settings, network, bridge adapter, advanced, promiscuous mode, allow all. Okay. And then we have to hit let's start. Okay, let's check if we are able to connect. Okay, here, here, and where were we? Docker run. Interesting. No worries with that. Let me just check one thing. Docker network ls docker. Okay, no worries with that. So let's create our containers quickly in MC this 𝗏𝗃𝗏 docker run. First of all, let's start with Wolverine Ubuntu, and network would be 𝗏𝗃𝗏 bridge. And then there would be Deadpool, Professor X -P port 8080 and Nginx. Let's see if it is working. So yeah, let's go. Quickly just inspect docker inspect Wolverine. So this is the IP. Let's ping this IP. Yes, it is working. Okay, now again with Deadpool, this IP, let's check. It is still not reachable, so MAC address has been assigned, but why is that? There is one actually in data link layer. We already have promiscuous mode on, so it should work, but it is not working. Let's see. So there is one catch over here. So it is a physical router. Okay, it is like physical router. And this device is basically a physical router. This device. Oh. Okay, so this is the physical router, this particular machine or router or switch, whichever you want to say. So it has actual ports available in it. Actual ports, we have physical ports. Okay, so there is some kind of rule that prevents on any physical port, like if we are using a cable, if we are using, let's see, it is a cable that we have used to connect to a particular machine. Okay, so there is one rule that is preventing preventing it to share multiple MAC on a same port, on same physical port. Okay, so that's why I think the MAC is not getting allocated, but no worries, we can anyway docker stop stop Wolverine Wolverine and which Deadpool. Both of them. Ping Professor. Docker inspect Professor X. Why is it not pinging? Let me delete this one as well. So X. So now this IP is allocated to, yeah, it is pinging. And if you can see over here, let's just go back to our 8080. Oh yeah, for IP would be this. Unable to connect. Yeah, exposed it to 8080, right? 8080 is connected. something is blocking the connection. I think we are able to ping this particular container. Curl hyphen connection diffused on port 80. I think there is one more thing that we need to check, which is sudo IP. It is taking the IP automatically, so there is not the issue, and we are able to ping it. Let's IP link very sorry, yeah. There is one command. I think promiscuous mode is by default off on my system. So here, what is the issue right now going on? We have our virtual machine. We have our host which is connected to network, which is obviously the Wi-Fi, and there is the virtual machine inside it. Yes, yeah. So we have there are so many things currently running on. First of all, there is a router which is connected to our host machine. Okay, then inside our host machine, then we have our VM. In VM we have our Docker, and in Docker we have this Mac VLAN. So what is happening over here? Uh, this particular Mac VLAN actually assigns actually allocated MAC addresses. Okay, since it is working on layer 2. Okay, layer 2 data link layer. It is mostly about Mac VLAN for hardware identification. Okay, so what is happening over here is it is using the Mac VLAN, and in physical this is kind of a switch. Okay, a physical it is connected to a physical port. Okay, so in that case what is happening, it does not allow more than two, it cannot handle more than two MAC addresses on a same port. Okay, that's why we are getting blocked. So this is the explanation. There is one actually trick, IPv set. Okay, set enp0s3. Yes, promise was on. Yes, promiscuous mode on. Okay, I hope this will allow us to, because we already have enabled promiscuous mode on our machine. Professor X, first of all, let's just, okay, Professor X is already there. I'm going to stop him. Container itself, but container itself. And then let's just check. I think we have to check it other way. There are other ways we can check it anywhere. So we have Deadpool, and let's just enable Wolverine as well. Okay. Docker, yes, we have these three containers running, and let's just inspect them once before. Professor X has the IP and gateway. Then Wolverine has the IP and gateway. Deadpool has the IP and the gateway. Okay. Docker exec -it. Which one was that? Let's just go into Wolverine. Bash apt update apt install -y IP route 2 and ifconfig. Oh, net tools. Sorry, net tools. So let's let it get installed. So what we'll be trying to do, oh yeah, there is one more ping, IP utils ping. Oh, it does not have access to the internet. Let me just check if I can go inside Professor X. Ping is also apt update. Not able to connect. Still not able to connect. Shall I restart my machine? One minute, let me restart the VM. Let's wait till the machine gets started. here you can see the update. Okay, here is, I think now it has started. Control-Shift-E. I need to remember these shortcuts. Okay, so where do we start? I'll just create all the containers again. Suppose there is 𝗘𝘅𝗽𝗋. Okay, let's just inspect them one by one. Tool, this is the IP. 𝗘𝘅𝗽𝗋, this is the IP, and Professor X IP is also mentioned. Now let's just check if we are able to ping all these containers. 1.2. Yeah, okay, it is reachable after some time. That is fine. 3, it is also reachable. Great. And 4, no response. So what we'll do here is we'll just go docker inspect docker exec -it deadpool bash apt update connecting connected working. Okay. Update is done. Apt install -y net tools IP route 2 and then IP utils ping. There is some issue. Apt install net tools IP route 2. I think it is still not able to connect to the internet. We cannot ping it from here. Okay, there is one more thing. Docker stop buffering. There is one more busy box. There is still SSH. Shell is still available. Ping 192.168.1.4. Still not able to reach. Ping 192.168.1.1. It is not able to connect to the net or to a router. Okay, to our gateway. Sorry. So yeah, that's how it is. It is getting blocked. So there is one more network which is even better than this. There one more mode. I'm just stashing these. My system and there is one more network that we can use. So right now we have created some of them. We can directly ping them for like we have Professor X. This one would be Professor X. This one would be Wolverine. And this would be Deadpool. Okay. We have tried to expose it. Let's check if at least our Professor X is working or not. Let me just check one more time I think for stop Professor X, since it is directly working on our network, maybe it is related to our, where did it go? Yeah. Let me remove this port for now. Okay. Inspect Professor X. Yeah, Professor X we have inspect, and let's just refresh. It should run. Why is it not running? Port 80. -F start worker process. What IP do is that? Some issue with this. No worries. Let's I'll troubleshoot it later. And I think for something I'm missing over here. Uh, Let me just disable this. Let me just enable promiscuous mode in my host machine. Sudo IP link set promiscuous WL. Some issue with this. Oh, okay. So right now, if you might have seen here, 80. We can do one more thing with this. Just as we have named it, we can provide IP address. IP address would be like 192.168.1.101. And if I just check inspect, so this is the IP. Let me check over here. For on 100 it is working well. Okay, on 100. Okay, now it is not working. Let's just see on 101. On 101 also it is not able to connect. Let me check if I can reach out to 101. Ping 192.168.1.0. Not reachable. So 𝗡𝗃𝗃𝗏 has this particular issue. There is one solution though for the same. We can use another mode here. If you have seen over here, this trunk bridge mode. So what it will do, it will create a sub network. Okay, 802 mode. Let me just remove this. Docker. First of all, clear. Let me clear this. Clear. Docker network create -d 𝗡𝗃𝗃𝗏. There is this driver and scope label mode. There is this mode that create d. Yeah, here. Help. Again, what we need to do, 𝗡𝗃𝗃𝗏 set --subnet. Subnet would be 192.168.1.0/24. Oh, there is one thing that we haven't done. if config this net mask. So let's create another 10.0.3.0/24. This is the subnet, and then there is a subnet we have configured. Then there is gateway. Gateway equal to 10.0.3.1 probably. I'm not sure if 0.1. Yes. Oh, unreachable. What's this unreachable? This is the gateway. Nmap scan for report gateway, nmap scan report for 3. This is the port. Nmap is one of very useful command when it comes to network reconnaissance. Okay, it might be handy when you use it in cyber security. Okay, -o parent would be em0s8.100. Okay. Name would be macnet. Okay. Now let's just see. Docker network ls. We have this macnet available. Okay. Let's just create some containers in this. Macnet IP. Let me just set up the IP 110.0.3.100. It would be what should I name it? Spidey. Okay. Venom. Let me just check. Oh, we have made a mistake over here. No worries. 10.0.3.100. We have named two IPs on the same. Host is unreachable. But if we see ifconfig, there is one network adapter that might, yes, this network adapter. This is a sub network adapter which has been created. Okay, so you can find it over here. It is for 𝗡𝗃𝗃𝗏 2 also. 𝗡𝗃𝗃𝗃𝗏, which is 802 mode. Okay, this one 802.1q trunk bridge mode. It said. Okay, so yeah. Inspect Spidey. Inspect Venom. Oh, Venom is not created. Venom is not created because we have provided the same IP to that. Great. Let's make it 01 and keep it like Ubuntu. Let's try to ping it. It is trying to ping, but getting unreachable. That. Okay, so no worries with that. We have seen 𝗡𝗃𝗃𝗏. 𝗡𝗃𝗃𝗏 is mostly for using hardware emulators so that they can have their own MAC address. There is some configuration that I might have missed over here. Okay, I'll look into it and then get back. So this is one of the network that we have seen. Okay, there are two modes, and then there is IP-VLAN also. Okay, IP-VLAN is much more MAC address mostly works on level 2. Okay, then there is IP-VLAN. IP-VLAN network driver. IP-VLAN network driver works on level 2 and level 3. Okay, level 2 would be data link layer, same as 𝗡𝗃𝗃𝗏, but it does not have that particular kind of like, yeah, it does not require MAC address spoofing or @0. This is Docker host. This is actual network router. Okay, and this is the subnet. So with same port, these two are connected. Okay, Docker network create plan -o IP-VLAN. So let's just create it. Docker network create -d IP-VLAN. IP-VLAN by default, I think there is by default the mode is L2. Here also we have to select the subnet and gateway. Then there is subnet 192.168.1.0/24. This is the subnet that we need to give. Then here is the gateway. gateway 192.168.1.1. This is the gateway, and -o parent equal to enp 0s3. Let's keep it 3 for now. Okay, then it is, what was that? Guardians. Okay. Guardian network. Pool overlaps with the pool overlaps with one other address space. Okay, I think first let me docker network rm magnet macmillan bridge. Let me just delete first docker rm docker stop running at pool. I'm stopping all the containers. Okay, all the containers are now trashed. Similarly, I'm just deleting these networks. These networks are deleted. If we can see, so no network is there. Now creating IP VLAN Guardian. Guardian is created. Here you can see IP VLAN is created. Now let's just create containers like docker run rocket. I'm just providing it 192.168.1. Oh, I made a mistake. Network where we have network. I'll just use BC box here. Docker inspect rocket. So yeah, ping 192.168. Here you can see MAC address is not allocated. Okay, 1.101. What's this? Still unreachable. Okay, let me check. Let me troubleshoot this. Right now it is pretty. We have seen everything. We have seen multiple different networks over here. I might be missing something that is causing us the trouble. Let's just go back to our documentation. We have a network create IP VLAN subnet gateway. Oh, we haven't set IP VLAN mode. -o IP VLAN mode. Okay, IP VLAN mode, which is L2 or level 2. guardian is deleted, one is created, and then we have MAC VLAN, IP VLAN. We have set the mode. One zero one. So yeah, there is one thing that we haven't checked yet. Like I have created this rocket. Okay, let's just create root, and IP would be 2. So if I go inside this container, it is very interesting that we can have this docker exec -it root dot sh. Okay, if I say IP header show IP header, so there are only one. Yeah, this Ethernet adapter is allocated. This is the IP. Okay, this is the IP that we can see. And IP route. So this is host IP, and this is the source. So default via it is reaching to our container ping 192.168.1.1. So it is able to ping. Okay, but somehow from external network we are not able to ping it. Okay, so it provides us a layer of security. IP VLAN. Suppose if you have database, you would not want others to access your database. Okay, if I'll just say ping rocket, so it can easily ping rocket. Okay, it can easily ping others, but not the reverse. Okay, from the bridge network, no one can access this. So this is how it will provide an isolation. So this is how this are. If I'll go check rocket and try to ping 192.168.1.1. Yes, I can ping it. Okay, but and if I check IP address, so this is the IP address 101. Okay, still it is not able to reach out. Okay, outer world cannot reach out this container. Okay, so here you can see, and I can still communicate with other containers in this. So which was root. Yeah, root is communicating. So that's how it provides a security layer. Okay, so this is for MAC VLAN. MAC VLAN assigns MAC address. Okay, it is directly connected to a router. Let me just put everything below. Okay. Yeah, so this is how it is looking right now. And let's just check for another one. So in this, we have MAC addresses allocated. Okay, MAC address allocation. Okay, allocation is done. So for identifying hardwares, okay, MAC address allocation is required. So if there is any emulator, IoT emulator is running on this container, so in that case MAC address is required. That's why MAC VLAN is used. And there is one more network type. Then there is this IP VLAN. Okay, let me just copy it. So we have IP VLAN with us. So IP VLAN also takes IP address from this. It takes IP address from our IP allocation. Let's increase it a little bit. IP allocation. Okay, it provides IP but not MAC. We have seen over here. Okay, we have seen. So MAC address is null. So one MAC address can have multiple IP addresses. So this is one IP. Okay, and this is for 𝗖𝗃𝗃𝗃. 𝗖𝗃𝗃 also have two modes. Okay, two modes, like one is this is for like GROOT, and we have rocket. So external world cannot be accessing it. Like if I try to access it through my this machine, okay, this is my machine. Okay, okay, let it be. So I cannot access from this machine to this particular container or this container, but they can have communication in between. Okay, they can have their own communication. Okay, these two have their communication established. So in that case, if we have some kind of database or something, so we can set up for that. We can set up the database server so that they can communicate. And there is one more thing. Let me just try it once. Like we have created Docker run GROOT busybox. Okay, Guardian. There is Starlord. IP would be 3 -p 8888 nginx. Let's see if it will work. Starlord. It is not showing IP. Okay, I think I need to delete that. Docker rm Starlord. But stop Starlord. I'll remove this for now and check if it is working or not. What was that? 113. Yeah, it is working. Okay, so in this has solved our one of the problem. Docker ps. So only the expose service, like here on port 80, it is nginx is running. So then only it can be accessed. Okay, Docker ps, like Docker, which one was that? Docker logs -f Starlord. So this has fixed our issue with uh, the issue that we have with Mac VLAN. Okay, now we can host any other service, like just like hosting it on another VM. Okay, in the same network. So yeah, this is IP VLAN. This is L2. It is still working on the data link layer. Then there is L3 mode also. L3 mode for this. I'll just, so here in, I think we have stretched quite a lot. Yeah. So DBNet, okay, database can work on this. We can anyway use this as a we can anyway anytime use it as the database. And where did it go? For network. Yeah, Mac VLAN. And so there is one difference between Mac VLAN and IP VLAN. Mac VLAN is for legacy applications that are that require physical layer 2 network, physical devices, okay, like IoT setup and other, and IoT emulators. Okay. However, for this IP VLAN is high density container setup where IP management is easier than managing MAC addresses. Okay, situation where physical device cannot be handled numerous MAC addresses. When like here in our situation, there is only one MAC. One MAC is for uh, this machine. Okay, IP address. Oh, this is the Mac. Okay, 2B. Oh no, this is for Docker. Yeah, this is the actual Mac. Okay, and here we are distributing this Mac or spoofing this Mac in so many other ways. So that's why we need this one. IP VLAN. Okay, IP VLAN is for that. And for layer 2 is similar to Mac VLAN, operates on layer 2 of OSI model. Just the difference is it does not require MAC address and allocates IP address. Okay. And there is one more thing. Yeah, for level 3 simplifies network routing by isolating traffic. So why is it simplifying? So the simplification over here is basically in transport layer it is easier to there are only packets. Okay, network traffic is only done through the packet and source and destination kind of thing. Okay, So legal scalable, when we are using scalable modern scalable setup, we have to set up highly scalable network. So IP VLAN would be the best. And uh, if we are setting like IoT or physical device emulation and other, then MAC address would be same. Okay. Routing is simplified in layer 3 as compared to layer 2. That's why L3 mode is even more better than even much better than other L2 mode. Okay. So this is all, and we'll see how can we integrate it in other. So 1 minute, let me just IP here. I think there is some kind of explanation. Containers attached directly to parent interface, no bridge used. Network gateway host, yeah, parent interface. This is ETH0 is the parent interface. Okay, we are directly. So Docker host 1 container. This is the MAC mode. Container 1, container 2, 10, 11, 12, 13. IP optional. IP is optional over here. This is IP VLAN mode. Okay, default L2 mode if not specified. Then there is subnet IP VLAN. This is L2 mode. Okay, this one is L2 mode. So here you can see network and other gateway. This is the gateway. There are 3 gateways and other containers on same network. Gateway and another container. So parent ID ETH0, ETH. So it has like in the MAC VLAN 802 mode. Okay, 802 mode. It has created a sub interface. So similarly in here we have a sub interface like front end, back end, credit card. There is VLAN ID 20, VLAN ID 30. There are a lot of things. Physical network, IP, yes, IP VLAN 3. So unless notified about the container network, the physical network does not have a route to their subnet. All containers can ping each other without a router. Okay, so it has internally, it has itself, if they share the same parent interface. Okay, so this has created a whole ecosystem of itself, whole container. So IPv3 is similar to the network. Okay, so let's just halt over here. If you have any question, I think there are some troubleshooting required for Mac VLAN, but we know where we stuck. If I find, I'll try to troubleshoot it, and if we find anything, then we'll surely have another demo. So let's just halt it here. We have quite a long video today. So thank you all. Have a nice day. Let's reconvene tomorrow for day 15.